Hi, hello, vanakkam, and welcome back to yet another episode on Little Law YouTube channel. So, in our first two videos, we saw about the introduction to Dynatrace, and we have also saw about the basics of Dynatrace and how does it work. In the second video, we saw about how to monitor the CPU usage, and also we saw about some of the common CPU bottlenecks that we observe during performance testing and also the tuning suggestions. So today in this video we are going to see about the databases. So we are going to see about how to monitor the database, and we will see each part of monitoring the database. So this will give you an insight of how to monitor the database and how to tell your client or the developer that there are some issues or there are some bottlenecks in the databases during the load test, because this will definitely help you to solve the performance bottlenecks, especially with the databases. So today we are completely going to discuss only about the databases. So the first part is, let me give you an example. So why do we need to monitor the database using Dynatrace? So how critical is that? So imagine you are running a busy restaurant and you have teams of chefs who are working in the kitchen to prepare delicious meals for your customers. The chef who are working in your restaurant, they need access to a pantry which is stocked with all the ingredients they need to cook their dishes. So now think of the database as your pantry. It's where all the important data and information for your restaurant are stored, such as the list of orders, the customer details, any inventory levels. Just like the pantry, the database needs to perform efficiently to keep the restaurant running smoothly. So during busy hours, when many customers place orders, the chefs will be working at full speed, preparing dishes, and they use ingredients from the pantry. Similarly, when the website or application experiences a surge in user activity, the databases will be processing a lot of requests, data requests from the application, like saving new customer information or retrieving order details or updating inventory levels. So here is where Dynatrace comes in. It's like having a dedicated manager who oversees the pantry and ensures everything is running smoothly. So Dynatrace is a powerful monitoring tool that keeps a close eye on the performance of our databases, just like our manager makes sure the pantry stays organized and well stocked. So Dynatrace tracks various metrics and analyzes the performances of our database in real time. Dynatrace also monitor things like how many data requests are being processed, how quickly the database responds to these requests, and whether there are any bottlenecks or slowdowns. Just like our manager can spot when the pantry is running low on the ingredients and if there are any issues with the kitchen workflow. So same way, Dynatrace can identify any performance problems in the databases. So why is this monitoring critical during performance testing? So well, performance testing is like conducting a stress test for a restaurant, and we want to know how well our chefs, the pantry, can handle a large number of customers and orders all at once. So by using Dynatrace to monitor the databases during performance testing, we can identify any potential problems before they become real issues for our customers. It helps us to catch any slow performances or slow responses, any excessive resource usage, or any other bottlenecks that might occur when our application is heavy under load. So now we will see how to monitor the databases and how to identify whether is there are really any bottlenecks in the system. So for that, I will go back to the dashboards here, and then to monitor the databases. So here under your applications and microservices, you will have your databases. So I'm clicking on the databases, and this trade management is the DB which I'm using for my application. So I'm clicking on trade management, and once you click on your trade management, you will see the dashboard for the databases. And here you can see there is databases service overview. And here there are different metrics which you can see. So for example, here I can click on this response time, and then I can view the percentage, 50th percentile, which is the average response time, and then I can monitor the 90th percentile response time and then the 99th percentile response time. So same way, I can monitor each and every different metrics in an individual view. But I want to view this in a multi-dimensional analysis so that I can understand that at what point of time a particular service or a response time or any other metrics has been increased or decreased, or is there any other spike. So for that, let me click on the multi-dimensional analysis. So here I'm clicking on the multi-dimensional analysis, and then let me choose this for at least 6 hours so that we can have a better view of the metrics. So now coming back to the metrics, so here let's choose, for example, here I'm choosing, so here we can choose any of the metrics here, or else we can even filter the request. So for now, I'm just starting with the response times. So let me go back to the screen here, and let me click on this three dots and click on show in data explorer. So here you can see I have the 50th percentile, the 90th percentile, and then the average percentile is at the bottom, the average response time, and then the 90th percentile response time is in the middle, and then the 99th response time is at the top. So now I want to add many other queries to the graph. So I'm clicking on add metric, and under add metric I'm going to add the connection success rate. So why the success rate is important when we are monitoring the database. So now let me create the query for connection success rate. So it is going to be a built-in service request. So I have the query with me. Let me just copy paste it so that I can save some time. So here I have the query, and then when I run the query, here you can see at the top there is this connection success rate. So why is this success rate important? Why do we need to monitor the success rate, or how beneficial is this going to add to the database monitoring? So this database connection success rate is a metric that measures how often our application successfully establishes connection to the database. It also tells us the percentage of connection attempts that were successful. So, what kind of bottlenecks do we observe when it comes to the connection success rate? So, to find if there are any bottlenecks related to the database connections, we can use monitoring tools like Dynatrace. So, these tools will give us a real time insights into the performance of the application. So, for example, we have to look for low success rate. That is the main bottleneck. So if there are low success rate, it means if the database connection success rate is low, it indicates that our application is facing difficulties in connecting to the databases. So you understood, right? So if the connection rate here, so here you can see the connection rate is steady and there are no issues at all. It's like 100%. You can see here it's like 100%. If there are any drop, or if the count comes low, it indicates that our application is facing difficulties in connecting to the database, and this could be due to your network issue or your database server overload or misconfiguration. So those three issues has to be fixed. And the next one is we have to check for frequent retries. So if you notice a high number of connection retries, it means our application is repeatedly attempting to establish connections, and this is a sign of bottleneck as the database may struggle to handle multiple connection requests. So this also has to be taken care, and we have to monitor for any new or like frequent retries to the system. And then coming back to the third bottleneck, which is examining the response time. So we have to measure the time it takes for our application to establish a connection with the database. And if the response times are consistently slow, it can lead to delays in data retrieval and processing. So, what are the suggestions to fix these bottlenecks? So, the first suggestion would be to optimize the database configuration. So, anytime any issues we face with the databases, the first suggestion would be to optimize the database connection. So, configuration. So, what kind of optimization should we do? The first thing is we have to make sure that our database server is poorly configured for the expected. So we have to make sure that our database server is poorly configured for the expected workload. So we have to adjust the settings such as the connection limits, the timeouts, and any caching to handle better incoming connections. And these can be discussed with the database administrators or the database team. So you'll have to advise them to increase or to optimize the connection limits, the timeouts, and the caching. And coming to the next point, so this is in most of the scenarios when you are in your interviews, you will be definitely asked this question. So what could be the another tuning suggestion? So the next one is the pool database connection. So when we implement connection pooling in our application, the connection pooling allows us to reuse the established connections instead of creating new ones for request. And this reduces the overhead of connection establishment. So we have to make sure that the database should have or should reuse the established connections. And then coming back to the third one, which is monitoring the database performance. So we have to use our monitoring tools to keep track of our database's performance metrics, and we have to identify any resource intensive queries and optimize them to improve the overall database efficiency. So we'll now move to the next metric. So the next metric is the connection failure rate. So far we saw about the success rate. So now we will see the connection failure rate. So let me add the query for the success failure rate here. I'm clicking on add metric and I'm clicking on the failure metric and I'm running the query. So since there is 0 percentage of failure rate, so here you can see at the bottom, so there is 0 percentage. So I will tell you what does this monitoring of failure rate brings you when it's monitoring the databases connections. So here I have added the monitoring monitoring metric for failure rate. So what does this failure rate means? So the database connection failure rate is a metric that measures the percentage of connection attempts made by our application to the database that results in failure. So in other words, it tells you how often our application tries to connect to the database but cannot establish a successful connection. So this is directly proportional to the successful connection rate. So that is what I'm trying to say. So it tells you that it is trying to connect to the database but cannot establish a successful connection. So that is where the failure rate comes in. So what kind of bottlenecks do you see when it comes to, or how do you find the bottlenecks? First of all, like how do you find with the failure rates? How do you find the bottlenecks when it comes to the failure rate? So the first thing is like we have to use the monitoring tools to find the bottlenecks, and then by analyzing the connection logs. So these monitoring tools will provide logs and statistics like the one like these graphs, and using them we can monitor the failure rate, and we have to check for any error messages, and also we have to identify the trends. So here you can see it is just around 0 percentage and there are no increase or decrease, so it just keeps on maintained in the zero. So there are no any failure rates in this test. So this is the trending, identifying the trending. So what are some of the common bottlenecks that leads to connection failure? So the first part is the resource limitation. So the database servers might be running out of resources like the CPU, the memory, or any disk space. So this will prevent from handling connection requests effectively. So that is the very first common bottleneck that leads to connection failures, which is the resource limitations. And the next point is the network issues. So poor network connectivity or high latency can cause connection timeouts and failures. And then the authentication problems. So if there are any incorrect or any outdated credentials which are used by the application to connect to the database, they also can lead to the authentication failures. And then coming back to the fourth bottleneck, which is the connection pooling misconfiguration. So if our application uses connection pooling and if there are any improper configurations, they can lead to connection issues. And then when it comes to the database server overload, so if there are like high database server load due to heavy traffic, and this can lead to connection failures. Why? Because the server struggles to handle any incoming connections. And then coming back to the last one, which is the firewall or security restrictions. Even the network firewalls or any security measures might block or limit the number of connections to the databases. So these are some of the common bottlenecks that leads to connection failures. So how to fix these bottlenecks? So you, when you are in the interview, so you must try to tell that these are some of the bottlenecks that you face and these are some of the techniques you fix. So for example, if the resource usage is high, so how do you fix it? So you have to optimize the resource usage by ensuring that the database server has sufficient resources and consider scaling up the hardware if needed. So you have to give these kind of suggestions to optimize the resource usage. So what about network optimization, which is the second bottleneck? So when there is some issues with the network, we have to improve the network connectivity, we have to reduce the latency, and we have to troubleshoot the network related issues. And then we had discussed about the credentials part. So we have to verify the credentials, we have to make sure, we have to double check and update the authentication credentials which are used by our application to connect to the databases. And then we saw about the pooling settings. So any connections to the pooling settings, we have to adjust the connection pooling settings to better match the application's requirements and database capabilities. And then we have the load balancing issues. So by implementing the load balancing strategies, we can distribute the connection request evenly across multiple database servers. And then when it comes to the last suggestion, which is the security configuration, so we have to review the firewall, we have to review the security settings, and we have to ensure that they don't block legitimate database connections. So by addressing the bottlenecks causing high connection failure rates, we can improve the reliability and performance of our applications interaction with the database. So now let's move on to the next metric. So the next metric is going to be the very common one, which is the number of errors. So I'm adding the metric here, and here is the command for it. So built-in service errors total count. So since this does not have any errors, so here we cannot find any such error. So here you can see number of errors is showing 0 for the entire. So error is very common. So if there are any errors, we have to find what kind of error is that, and we will have to give some suggestions to fix it, or we have to find the root cause of the error and we have to fix that. So when it comes to the next one, which is the request count, so let me add the metric. So I'm adding the metric here and I'm adding the request count and I'm running the query. So here at the top, so here you can see for every second, you can see there are these around like 2.75k requests are coming to the system. So we will see what this request count is and how does it help us to improve the database performance. So this is another important metric in database monitoring, and this request count refers to the number of requests or queries that are made to the databases from our application or service over a specific time period, and it helps us to understand the level of database activity and the workload our application generates. And by monitoring this metric, we can identify any potential bottlenecks and we can take proactive measures to optimize our database performance. So how can we identify the bottleneck using the request count metric? So the first point is for we have to look for any sudden spike in request count. So if we notice a sudden and significant increase in the request count, it could indicate a sudden surge in user activity or traffic to your application. So while increased usage is generally good, it might also lead to performance issues if our database cannot handle the increased load efficiently. And coming to the second bottleneck, which is the high and consistent request count. So, consistently high request count over time might indicate that our application or services are frequently querying the databases, and it is essential to ensure that our database can handle the sustained load without slowing down or encountering performance problems. And then when it comes to the third bottleneck, which is the request count discrepancy. So we have to check for any disparities in request counts between different parts of our applications or services. And the significant differences may highlight certain components or functionalities that are putting more load on the database than others. So what are some of the common bottlenecks in the solution? So this is again another. So I'm adding lots and lots of database bottlenecks that you can observe in your application, and I'm also giving you the solution. So please do remember these questions and answers while you do your monitoring or while you are attending your interviews. So the first one is insufficient hardware resource. So if the database server lacks sufficient CPU, memory, or storage resources, it might struggle to handle the high request count effectively. And what could be the solution? So we have to upgrade the hardware or we have to optimize for any existing resources to accommodate the workload. And then the next point is the most important or the most critical one, which is the inefficient queries. So because of the poorly optimized or complex database queries, which can slow down the response times and lead to increased request count. So we have to ensure that the database queries are properly optimized, they are indexed, and they use the best practice to improve their performance. And again, we have the connection pooling issues we have already discussed. So we have to increase the request. So for example, like if our application does not implement connection pooling correctly, it may create and close too many connections to the databases by increasing the request or by counting unnecessarily. So proper configuration and managing connection pooling can avoid this bottleneck. And coming back to the next one, which is locking and blocking, which is the most common bottleneck. So when there are concurrent requests to the same data, it might result in locking and blocking, which cause delays and it can increase the request count. So we have to optimize our database schemas, we have to optimize the queries and any transactions to minimize the contention and improve concurrency. And when it comes to the next part, which is the inadequate indexing, so any lack of appropriate indexes on frequently queried columns can lead to full table scans and slow down database responses and contributes to higher request counts. So we have to ensure that our database has the necessary indexes to optimize query performance. And then when it comes to the slow storage input output, so the slow disk input output can impact the database performance and it can lead to a higher request count as queries take longer to complete. So we have to consider using faster storage solutions or optimizing disk access to alleviate this bottleneck. And then the last bottleneck and the solution is going to be the network latency. So if our database server is located remotely or if there are any network latencies, it can increase the time it takes to process requests and contribute to a higher request count. So optimizing the network configurations or considering using a nearby database server to reduce the latencies. So now we will see our next metric, which is the response time. So I'm adding the metric, which is the response time. So here you can see the built-in service and then the response time, and then I'm running the query. Let me search for the response time here. So here you can see the response times for the application. So let me tell you what or why do we need the response times metric. So this response time metric in database monitoring refers to the time taken for the database to process a request or query from our application and return the result. So this is not something like the response times which we see in the application as part of the transaction. So instead, they are the time taken for the database to process a request or query from our application and return the result. So it measures how quickly the database can respond to the incoming request, and it is a critical metric for understanding the performance and efficiency of our database. So how can we identify the bottleneck using response time metrics? So the first bottleneck is high response time. So here you can see the response times are almost closer to 2.7 to 3 milliseconds. But what if there are high? They are like going more than 15 milliseconds or 100 milliseconds. Even you can even see that in your application when if there are really some bottlenecks. So if you observe consistently high response times, it indicates that the database is taking longer than expected to process any queries, and this could be due to various factors that might be affecting the database's performance. And when it comes to the next bottleneck, which is the response time variation, so we have to look for any fluctuations in response times over time, and if we notice any significant variations, it might be an indication of intermittent issues or any workload spikes that are impacting the database performance. So what are some of the common bottlenecks and solutions? So the first part is the query optimizations. So if there are any poorly optimized queries, it can significantly increase your response times. So we have to analyze the slow performing queries and optimize them by adding the appropriate indexes. We have to rewrite the query logic, and we have to reduce the complexity. And then when it comes to insufficient hardware resources, so if the database server does not have enough CPU or memory resources, it might struggle to handle the workload efficiently. So we have to consider upgrading the hardware, or we have to optimize the resource allocation to improve the response time. So when it comes to the contention and locking, so previously in our previous request count we saw about locking and blocking. So here it is contention and locking. So what is this contention and locking? So when there are concurrent queries that access the same data, that might lead to contention and locking issues, which can cause delays in response time. So we have to optimize the transactions. We have to use row level locking and reduce contention to improve the response times. So when it comes to the disk input output bottlenecks, so the slow disk input output can negatively impact the database performance, and we have to ensure that our database storage solutions can handle the workload and consider using faster storage options to reduce disk access times. And then same way we have the network latencies, which we have discussed already, and then we have the database configurations. So we have to review our database configuration settings to ensure they are optimized for our application's workload. So we have to adjust settings like buffer sizes, the connection limits, and cache configurations for better performance. And then next comes the most common solution and the most common bottleneck, which is the database indexing. So if there are any inadequate or missing indexes, which can lead to slower query execution, so we have to verify that our databases has the necessary indexes to optimize response times for frequently accessed data. And when it comes to database version and patching, any outdated database versions or missing patches can impact performance. So we have to keep our database software up to date to take advantage of performance improvements and bug fixes. And when it comes to connection pooling issues, any inefficient connection pooling can lead to longer wait times for database connections, which affects the response times. So we have to optimize the connection pooling settings, or we have to use the connection pooling mechanisms provided by our application framework. So now we will move on to the next metric, which is the successful connections. So I'm adding the metric and I'm adding the successful connections here, and then let's run the query. Let's search for this. So here you can see the successful connections, which is almost 100%. So this is something similar to what we have at the beginning, which is the success rate. So the number of successful connections. So let's see how does this successful connections helps us to monitor the database, and how does it help us to monitor the bottlenecks when it comes to the databases. So in Dynatrace, the successful connections refers to the number of times our application successfully establishes connection to the database, and it tracks the connection attempts made by our application that resulted in successful communication with the databases. So we have to see for two bottlenecks. One is the low successful connections. So if we notice a low number of successful connections, it means that our application is facing difficulties in establishing connections to the database, and this could lead to various issues affecting the connection process. And the next one, which is the connection timeouts. So we have to look for any frequent connection timeouts or failures, and that can be an indicative of bottlenecks that are hindering our application's ability to connect to the database. And now we will move on to the next part, which is the related services. So here you can see it contains two services, which is the Easy Trade Login service and then the Easy Trade Manager service. So here you can also see the throughput, which is we are getting one request per minute, and for this Easy Trade Manager we're getting 24 requests per minute, and there are no failure rates. So in case if you want to watch a detailed view, so here you can see the graph of this, and then again same way for this one. So this is the related services. We have to understand if there are, so why do we need to see this related services? So for example, if we want to understand that if there are any issues in these services connecting to the databases, so we have to understand what kind of or how many connections or how many requests are coming at a time, and are they creating any issues to the databases. So we have to monitor even these related services. So by clicking on the backtrace, we can see the backtrace values here. So overall, we have got these many number of incoming requests for each of these requests, and then we are getting number of outgoing calls. And we also have to check for any failed calls as part of these requests. So it is very important to do a backtrace of these incoming requests. So now coming back to the statement types. So here this SQL queries or procedures is the important metric which we have to monitor. So I'm clicking on the SQL queries or procedures. So this will take me to the SQL queries which are part of my application or my databases. So here it will show me what are the queries and what are their total time. So here you can see it shows 3.46 seconds per minute. So it takes for executing one time per minute, and then the response time for these queries is around 2.25 milliseconds, and the slowest time it took is around 4.5 milliseconds. So in case if I want to sort it down, so here you can see, so this is the so far the slowest query. So here again you can see the total time it takes is 46.4 milliseconds per minute, and the response time of this query is 7.09 milliseconds, and then the slowest is 12.6 milliseconds. So this will tell you like why or how much time does it take to query. And when you go through the query, you can just find out like what are all the data does it bring, or are they really important, or even you can start tuning these queries. So by doing this, you can improve the performance, and you can reduce the response time. So that is the real improvement of this application. So when you are seeing, so this application, since they are like highly tuned, so you might not see any applications which has a response time more than 10 or 15 or 20 milliseconds, 20 seconds. But in case if you are finding a query which are having response times of a higher quantity, so you will have to give suggestions to reduce their response time. So you'll have to go to the query, you'll have to find like what are all the data it is bringing to the application, and you have to check whether they really need, and you also have to check for any tuning suggestions, something like joins, whether what kind of joins do they use, whether it's left join or right join or outer join. So you'll have to give a lot of suggestions, and you'll have to tune the queries. So this is something which is very important. So you'll have to go and find what are all the statements and what are all the queries, and what is the top query which takes more time, and how many requests does it send every time. So this is another important part. And then coming back to the Dynatrace, so we saw about the metrics, and then we saw about the SQL queries. And so this here you can see, so this is the some of the top queries which has been involved in the application. And with that, I come to an end, and I believe this video would be very useful. So in fact, I have shared you lots and lots of informations, and this can help you in your performance engineering activities, and this can even help you in your interviews. So please don't forget to subscribe to our channel for more informative and interesting videos. So until I meet you in another interesting video, it's bye bye from Vasan Shanmugam and Little's Law.